Continuing with problem number 6. Had to change videos, but it's like I was saying, what's weird about this question is they're only talking about one angle, okay? So, or you're thinking of it as one angle and you're thinking of this as the other angle. But how I would set this up is basically this angle and that angle add up to 90. That's what I was saying earlier about the internal sum. Okay? And then it says one angle is 4 times the other one. And I don't know which one's bigger. It doesn't matter. I'll figure it out. But let me just say if I said, okay, if I said y equals this, and what this means is, take a look. What it says here is they would be the same if I took the smaller one and multiplied it by 4, because the other one was 4 times larger. Okay? So there's my two equations. So you can see here I can plug this in for y. And I would say x plus 4x equals 90. Divide by 5, and x equals 18. Okay. And then to find the other one, I'll go back in here and plug it in. Say y equals 4 times 18, and that comes out to 72. Okay. So I wouldn't really answer this as a coordinate point because it is a word problem, but I would say that's the larger. Okay. And there's a smaller angle. Okay. Okay. Moving on. Right, so the next thing we're going to go ahead and talk about here is systems with infinitely many solutions or no solutions. And so what I actually did here, the questions, I didn't like the examples that they gave, okay? So I went ahead and kind of picked some new ones. And so what I'm going to do here is I'm going to cross this question out, and I'm going to say x equals negative 2y plus 4 and 3.5x plus 7y equals 14. So let's solve this, and then we'll kind of get back into what it actually means here. So if I was to solve this thing, I say, hey, well, look, this is solved for x, so I can take this and plug it in right there. So I'm going to say 3.5 times negative 2y plus 4 plus 7y equals 14. And I'll distribute this in, and that gives me negative 7y plus 14 plus 7y equals 14. Now if I combine like terms, I get negative 7 and positive 7 cross out, so I get 14 equals 14. Well, what you notice here is I was solving for a variable, and the variable disappeared. So the question is, so what does that mean in terms of the answer? This is an example of, and we looked at pictures in previous units, of infinitely many solutions. Okay. And how do I know that is, well, how I know is all my variables disappeared, and I have a true statement where 14 equals 14. And what that means is 14 always equals 14. So what it means is that these two equations are actually the same equation. I don't really have the room for it here, but if I solved for this y, it would equal, sorry, I solved for x, it would equal that. Or I turned this into the standard form, it would equal that, or something close to the standard form. So it's a way to look and see here how if everything goes away, I'm talking about the variables, and you get a true statement, 10 equals 10, 14 equals 14, 20 equals 20, it's infinitely many solutions. Now, down here, like I said, I'm going to cross these out. I'm going to pick another question. I'm going to pick y equals 3x minus 11, and y equals negative 3x, or negative y minus 3x equals negative 13. And I'll do the same thing. I can take this and plug it in for the y. I'll come do that up here, so I get 3x minus 11 minus 3x equals negative 13. 3x and negative 3x cross out. And so once again here, I got all the variables to disappear. However, in this case, I'm going to say no solution because negative 11 does not equal negative 13. Those are not the same value on both sides, so it's no solution. So you can see both the variables crossed out, true statement, false statement.